This is a video for Math 2-3. This is the problem from page 493, number 2. This is in Lesson 2, Investigation 1 of Book 1, Unit 7, which has to do with quadratic equations. This problem is about using distribution in a real-world situation. The problem up here says, Mrs. Parkhurst, one of the Sturgis mathematics teachers, suggested another way to find a profit function that considers all factors. What our job is to check each of her steps and explain why it's correct. I'm going to do that by writing out some algebra steps and by talking about why they're valid. Here's the first part. Since the number of tickets sold n, we need to know what n is, so let's write down that n, I want black, n equals the number of tickets sold. And the reason I'm writing down my variables, what the variables stand for, is it's very important later on to understand what things actually mean as we go. Not just power through things and try and do each step as quick as we can. So, since the number of tickets sold n is related to the ticket price x, I'll just write down here that x is the ticket price. And then it says that n is related to x by the linear function n equals 200 minus 10x. They point out that this is a linear function because the terminology we use talks about quadratic equations in terms of the product of two linear equations. But we'll get to that a lot more later. For now, let's concentrate on the fact that we've been given an equation. N equals 200 minus 10x. So I know that n, which is the number of tickets sold, is found by 200 minus 10x. And I want to point out that they give me the function here, and they give me the function for income here, but I'm rewriting it. And the reason I'm doing that is to get a better understanding. If you take the time to do this, it's a lot easier to do these problems, and you end up spending less time on the whole problem if you start kind of preloading it at the beginning. I'm taking longer to do it here than I would ordinarily once I get good at it. The income from ticket sales will be related to ticket price by this function, I equals x, which remember x is the price, times n. I'm pointing at 200 minus 10x, but notice I said n because n equals that, so I'm doing the substitution. Income is always the price of something times how many you sell. And here we're selling this many based on the price. That gives me a function I for income, which is based only on the price x. So I've got a function for I, the income, which is in one variable only. And that's really important because it's the only way I can solve these things. So this right here is what we're trying to get to. And Mrs. Parkhurst, the teacher in this problem, came up with this function, and I think I've now explained why. That's the income. Next step. Again, she gives us some information. The cost C for food. Let's write that down. C is the cost of food. But we know there's more than one type of expense. There's fixed costs, and then there's the costs that depend on another variable. In this case, the cost C is related to the number of tickets sold. So that means that, again, we have an expression where we're going to use our equation n. Remember that the variable n equaled 200 minus 10x, which means that the cost of the food also depends on the price. How much food we sell depends on how many people come to the show, and how many people come to the show depends on the ticket price. So you're putting all these puzzle pieces together so that all we have are equations in the equations that relate to x, the ticket price. So C equals 5 times the number of tickets, but this right here, that's the number of tickets. So we're going to substitute in that equation for n, 200 minus 10x. So the step here, the cost for the food will be related to ticket price by this function. And I'll write it down again. C equals 5 times 200 minus 10x. The next part is another kind of expense. Cost for the DJ, the security, and the cleanup. Those don't depend on how many people come, regardless of the number of students who attend the party. So that's another cost. Right there. We call that a fixed cost. And we're going to use that fixed cost in the next step to put that together with the costs. So, our costs or expenses are the price for the food, which is 5 times 200 minus 10x. That was the function C. But there's also $250 in fixed costs for the DJ, security, and cleanup. So now we're looking for a profit function. And profit is always pi. P equals I minus E. Where I is the income and E is the expenses. So we're going to build this function by putting in the equation for income, which was x times 200 minus 10x. And we're going to subtract from that E, the expenses. E is this whole equation right here. Notice that in expenses, we've got positive numbers. But since we're subtracting E, we've got to make all those negative numbers. I'm going to have to try to write a little smaller here. So P equals x times 200 minus 10x. And then we're subtracting the parts of E. Minus 5 times 200 minus 10x. And then minus 250. Whenever you're dealing with profit, your income should be positive, but your expenses should be negative. So this is a negative 5. We take away $5 for each ticket sold, and we have to take away $250 from our profit. So that should explain the part about putting the function together. The last part of this that I want to talk about is using distribution. This kind of carries over to problem 3 on the same page, but I think now is a good place to deal with it. We've got a couple of different parts of this. One of the parts is the income. That's x, x times 200 minus 10x. We've got to use the distributive property on this. The x gets multiplied by the 200 and by the negative 10x. Please notice that these are both linear equations. Y equals x, that would just be a straight line. And this would also just be a straight line with a y-intercept of 200 and a slope of negative 10. What we're doing is we're taking this linear equation, the really simple one, and multiplying it by this more complicated linear equation. And when we multiply those together, we get 200x minus 10x squared. So that's part of our profit. That's the income part. Next, we had some costs. The costs were, we're going to do minus 5 times the number of tickets sold, which is negative 200. Sorry, which is 200 minus 10x. We're going to do that multiplication. We'll get negative $1,000. And then since we're taking a negative times a negative here, that gives us a positive 50x. And it's important that we know that this number right here is a positive because it's a negative times a negative. But we've also got a minus 250 for the DJ, security, and cleanup. And that gives us another part of this where we need to combine these terms. But we're not doing that quite yet. That'll happen in the next problem. So this one is done.